At a distance of almost 3.7 billion kilometers from the Sun, there exists a small, dark world that once was the 9th planet of the solar system. Today, Pluto is officially just a trans-Neptunian object. Shortly after its demotion from planet status, NASA's New Horizons spacecraft reached this previously almost unknown world. The measurements taken astonished everyone, and NASA was able to release real images of Pluto for the first time. Now, we can't wait to embark on a journey to one of the most unusual celestial bodies in the solar system. Pluto, a world in darkness. Imagine yourself as a pioneer on Pluto, stepping off the spacecraft onto this mysterious dark world for the first time. In the vastness of space, the sun shines as a tiny, dim sphere. It's a strange, cold world, and you are currently covered in a large shadow. In the twilight, you explore the extraordinarily fragile surface. This world is quiet, truly very quiet. Due to its low gravity, moving around is extremely challenging. The gravitational force is only 0.063 times that of Earth, causing you to bounce like a feather. Progressing across the planet is difficult for you. Your boots are equipped with spikes and studs so you can cling to the surface. With great effort and difficulty, you manage to gather a sample of the rock. Then you climb back into your space capsule to land in another location on the dwarf planet and collect more samples. You've trained rigorously for this mission for many years. You were prepared for the unusual situation of the low gravity on the icy surface of the planet. Pluto is unique, somber, and yet beautiful. It's a sublime moment. Standing on this small icy world so far from the sun, after a few hours, the mission ends. The surface temperature, at minus 351 degrees Fahrenheit, allows for only brief stays. You take a few more photos of the sun and then begin your journey home. This is what life would be like for people landing on Pluto for the first time, in the twilight of the outer reaches of the solar system. This celestial body is barely illuminated during the day. The sun appears as a small, faint, yellow dot in the distance. For a long time, researchers thought that Pluto, being so far away, must be a dead and dull realm of rock and ice. But then they were in for a surprise. Pluto, located at a distance of about 40 astronomical units, is the closest of the so-called trans-Neptunian objects. Since its discovery in 1930, Pluto was the 9th planet, but in 2006, it was reclassified as a dwarf planet. This status is shared by a whole host of recently discovered planets that orbit our star at the farthest reaches of the solar system in almost complete darkness. The fact that Pluto was removed from the ranks of official planets was met with regret by many, even though little was known about Pluto. People had grown accustomed to the idea of there being 9 primary planets since 1930. For a long time, no one suspected that the Kuiper belt would reveal many more dwarf planets. Sedna, which is only slightly smaller than Pluto, presented scientists with a choice of whether to classify these and many other newly discovered objects as planets or draw a line. Since Pluto bears much more resemblance to trans-Neptunian dwarf planets than its neighbors Uranus and Neptune, scientists decided to strip Pluto of its planet status. Since then, it's officially known only as 134,340 Pluto. From darkness to light. It's almost ironic that shortly after its demotion, Pluto showed just how fascinating and unique it truly is. Pluto is extremely challenging to observe, and even in images taken by the Hubble Space Telescope, the dwarf planet appeared as a hazy brown disk without any surface details. Since it was virtually impossible to adequately study Pluto from a distance using telescopes, NASA sent the unmanned New Horizons probe to Pluto in the same year it was reclassified. The probe took 9 years and 8 months to reach its distant target. When it finally reached its primary objective in 2015, New Horizons immediately went to work, astonishing not only scientists, but everyone. In a very short time, the probe gathered 6 gigabytes of information, and it took over a year to transmit this massive amount of data back to Earth. To this day, planetary-scale researchers continue to analyze the data collected. Up until that moment, no human had seen Pluto's surface up close. Suddenly, before the curious scientists, a colorful and apparently very active world was revealed. Images of the extraordinarily varied structured surface of the planet uncovered unexpected geological activity. Although New Horizons couldn't penetrate the planet's core, its instruments provided data that allowed for the first conclusions about the planet's structure. According to the obtained model, Pluto has a solid core about 1056 miles thick, consisting of a mixture of various substances and elements. The upper layers consist of water, ice, and rocky materials. The thickness of the ice crust in some places likely reaches 186 miles. It's entirely possible that beneath this ice layer, Pluto carries liquid water. Active geothermal structures and ice volcanoes suggest that Pluto's core holds heat. According to some hypotheses, Pluto's core might generate enough heat to partially melt the icy mantle. In this case, deep beneath the surface of the dwarf planet, a highly saline, toxic ocean containing a significant amount of dissolved ammonia could be concealed. Quite unlike Earth, geological processes on Pluto are less dependent on water, ice, and rocky materials. Instead, this planet is driven by the massive crystalline gases such as nitrogen, methane, and carbon monoxide. Planet with a heart, Tambar region. Our journey across Pluto's surface begins with the brightest and most studied area, the Tambar region. This extensive region in the equatorial zone of the dwarf planet resembles a heart and is unofficially referred to as Pluto's heart. With a size of approximately 1429 miles, this region covers about a quarter of the entire celestial body's surface. The heart is divided into a bright left portion and a darker right one. The left part forms a landscape called Planitia satellite or Plan's satellite. Plan's satellite has a diameter of 927 miles, and on the topographic map, it appears as an extensive plain with a thick layer of nitrogen ice, methane, and solid methane. These substances have a bright color, causing some areas of the plain to reflect up to 90% of the incoming light. There are almost no craters here, indicating that the region is geologically very young. Plan's satellite likely formed about 100 million years ago when Pluto collided with a large celestial body. The impact left behind a huge crater that was subsequently filled with materials from the warm depths of the dwarf planet. This process resulted in a unique honeycomb-like structure that is exceptionally dynamic. A comparison with observations from the new James Webb Space Telescope revealed that over the last 8 years, these structures have migrated significantly, indicating ongoing geological activity. The Tambar region borders relatively high mountain ranges. Hilary Montes, located to the west of Plan's satellite, may not be among the largest in the solar system, but they are still relatively large. Their height reaches approximately 1.86 miles. Townsend Montes is located in the southern part of the heart. Some of these mountains rise more than 3.72 miles above the average surface level of the dwarf planet, forming the highest mountain range on Pluto. Interestingly, these rocks are likely primarily composed of water ice. At Pluto's low temperatures, water ice is as hard as rock. Cryovolcanism on Pluto. Further south, a deep depression shapes Pluto's outer appearance. It is surrounded by massive, layered ice ridges and cliffs. These structures display clear signs of cryovolcanism. The surrounding rocks most likely represent solidified materials from past eruptions. Thanks to new color images, researchers were able to discern details about the chemical composition of these eruptions, shedding light on Pluto's internal structure. The eastern part of the Tambar region is darker, and the landscape here is much older. Crater ages are likely in the billions of years, formed by asteroid or comet impacts. Unlike Plan's satellite, this region shows no signs of active geological processes. If we continue eastward along the equator, we will encounter a chain of dark spots known as maculae. High mountain ranges traverse the landscape here, stretching for hundreds of kilometers. The formation of the maculae remains a mystery that scientists are currently investigating. There is suspicion that their dark color results from a combination of impact craters and tholins. Tholins are complex organic compounds that form as a result of high-energy radiation interacting with simple molecules in the atmospheres of celestial bodies, affecting their optical properties. Lowell region. We leave the harsh world of the maculae behind and venture further north. There lies the Lowell region, an extensive valley that surrounds Pluto's north pole. Because Pluto's axis of rotation has a significant tilt relative to the plane of its orbit, this region is the brightest on the planet. Pluto always moves in such a way that its north pole faces the sun. There is suspicion that this is why Pluto's atmospheric density has tripled over the past 30 years, despite the increasing distance from the sun. It's likely that solar radiation causes nitrogen ice to evaporate, which then settles at the pole and enters the dwarf planet's atmosphere. Charon. Pluto's peculiar motion has a significant cause: its highly inclined orbit with cyclic oscillations around a focal point, influenced by Charon, Pluto's moon. Charon, Pluto's moon, is relatively large, with a diameter of about 753 miles. Pluto itself has a diameter of about 1476 miles. These two bodies revolve around each other at an average distance of only 12,172 miles. Both celestial bodies resemble more of a binary system than a planet and moon, although Pluto clearly dominates in this pair. The celestial dance of these two bodies was first documented by the New Horizons spacecraft and is currently the subject of intensive research. Charon is not only quite large for a moon but also shares many similarities with Pluto. However, its surface is even darker. Nevertheless, images from New Horizons revealed evidence of water ice mixed with methane and nitrogen, as well as unusual geological activity. Experts suspect that the Kuiper belt will continue to hold potential for new discoveries for several more decades. So far, only a tiny portion of this region in our solar system is known. Tell us, what do you think about Pluto and the images obtained from NASA? Do you have any guesses about what beautiful, incredible, and shocking discoveries may still await us in the Kuiper belt?